This is my intermediate algebra course. Today we're going to prepare for the second test of the course. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As I mentioned in the first part of the course, there are some subjects where you can study an hour the night before and get a really good score on the test, but that's not how math works. With math, you need to spend at least 2 days preparing for a test, and really 3 or 4 days is the minimum that you need to do really well on a math test. But it doesn't matter how many times you tell students to study for a test, they're not going to do it. So in order to force you to do at least some studying, we're going to do a practice test right now together. And I'm going to give you a practice test for homework, as we did in the first part of the course. And these practice tests are not only going to force you to do some studying for the test, but they're also going to familiarize you with the format of the test. Also, this video is pretty long, but that's because I'm explaining every step of every problem. When you take the test, you don't have to do that. You have to show some work, but you can move a lot faster, so don't be discouraged that this video is kind of long. When you take the test, it's not necessarily going to take you 2 hours to finish it. If it does take 2 hours, that's okay. I don't really care how long it takes you to finish the test. You can even take a break in between if you want, as long as you don't, consult with a textbook or cheat. You need to be able to do this without any help from anything. But all I care about is that you can demonstrate that you know this material and you can recall this information without having to constantly look to something else. Also, not every variation of every problem that we covered is going to be on these practice tests. So if you want to make sure that you're completely ready, you need to go back and look at every variation of every problem that we did. These tests are just kind of examples of the types of problems that you would see, but they don't represent every variation that you could possibly see of these problems. Each problem is worth 4 points for a total of 100 points. Same with all my tests. And I want you to attempt each one of these problems before watching me do the problem. So I want you to try number 1 on your own. And if you get stuck, that's okay. We're reviewing. This is helping you to review the information. So if you get stuck, that's completely fine. But if you attempt the problem and get stuck, that gives you valuable information. That means that you don't know enough to do well on the test. But if you can do this problem on your own, that means that you may not have to do a lot of review when it comes to this particular type of problem. Now remember, there's a lot of different variations of the problem, so you have to be careful when you study, but doing the problem on your own gives you very valuable information. So go ahead and try number 1. Again, if you get stuck, that's okay. And when you come back, we'll do it together. Okay, we're back. So it tells us to graph this quadratic expression here. If we set it equal to y, it's a quadratic equation. When you're graphing a quadratic expression, the most important point to draw is the vertex. So we need to know, how do you find the vertex? Well, the first question we ask is, what form is the expression in? Well, this is intercept form. And I'm going to go ahead and write that. You don't have to write the form on the actual test, but just to help us, I'm going to do that. So a is -1, m is 3, and n is -1. Again, you don't have to do this on the test. I mean, you do have to, you have to do it, you just don't have to write all of this stuff necessarily. So to find the vertex, when we're in intercept form, the vertex is equal to m plus n over 2. So that's 3 plus negative 1 over 2, which is equal to 1. So that's the x value of the vertex. And the y value of the vertex we can find just by plugging in 1 to the original equation. And when we do that, we get a double negative. And simplifying, we get 4. So 1, 4 is the vertex. So I'm going to plot that up here. And it says write the coordinates of the vertex, which we just did, and 2 other points, one on each side of the line of symmetry. We didn't actually write the coordinates yet. Let me go ahead and do that. So 1, 4. Now, this problem is kind of ambiguous in the sense that it doesn't tell you if you have to write the coordinates on the graph or down here. It's probably best to write the coordinates on the graph, but if you just want to write them down here, I don't think I really care. But if you can fit the coordinates on the graph, that's probably better to do it that way, because we can see exactly, what point you're talking about. So let's find 2 other points. Now this is in the quadratic equation is in intercept form, so that means we can see the x-intercepts just by looking at it. That's these numbers here. So 3, 0, and negative 1, 0 are the x-intercepts. So now we're just going to connect the dots, and we could find some other points, but the problem doesn't really tell us to be any more precise than 3 points, so you don't really have to do that. Your graph doesn't have to be perfect. You just have to have the points that it's asking for. So let's write the coordinates negative 1, 0, and 3, 0. So there you go. We're done with problem number 1. So if you got that right, excellent. Okay, on to number 2. It says find the coordinates of the focus of the parabola in problem number 1. So go ahead and do problem number 2. Again, if you get stuck, that's okay. But attempt number 2, see if you can do it. And when you come back, we'll attempt the problem together. Okay, we're back. Find the coordinates of the focus. Now, the x value of the focus is the x value of the vertex, and the y value of the focus is the y value of the vertex plus p. So that's something you have to remember. To find the directrix, remember it's y is, to find the equation of the directrix, it's y is equal to vy minus p, but we don't need that in this part of the problem. So the x value of the vertex we found is 1. The y value of the vertex is 4, but we don't know what p is. So we can't do anything. We're stuck. So really the first part of this problem is to find p. But we know that p is equal to 1 over 4a. The problem is, what is a? Well, a is always that number. Look at these 3 forms of a quadratic expression. It's always that number in front. So in this case, a is negative 1. We found that down here. You see this orange highlight here. We found a is negative 1. So we can just plug in negative 1 for a, and we get negative 1/4 is p. So now we can write the coordinates of the focus again, the x value of the focus is the x value of the vertex. The y value of the focus is the y value of the vertex, which is 4, plus p, and we just found p is negative 1/4. So now simplifying, 4 plus negative 1/4 is 3 3/4. So that's those are the coordinates of the focus, and we can rectangle that. And it doesn't tell us to actually draw it on the graph, but if we go down here, let's check to make sure this makes sense. Remember, the focus is always inside the parabola. So 3 3/4 will be about there, so that makes sense. It's always pretty close to the vertex, or usually pretty close to the vertex. Okay, so if you got that one right, excellent. Go ahead and try number 3. When you come back, we'll do it together. Okay, we're back. So the line of symmetry is really easy. It's just x is equal to whatever the x value of the vertex is. And we know the x value of the vertex is 1, so we're done. Pretty easy. Now, again, these two problems, they don't ask us specifically to draw these things on the graph. So sometimes you'll be asked to draw them on the graph, sometimes you won't. If you don't follow directions closely, then you're going to lose points. Remember, in school, following the directions is extremely important. Teachers love to just take off points because you're not following the directions. They enjoy it. Okay, so we found the equation of the line of symmetry, and we need the equation of the directrix line. So remember, you have to recall that that's y is equal to the y value of the vertex minus p. So the y value of the vertex is 4, and p we found is negative 1/4. Remember, we found that in the previous problem here. So that's a double negative, so we get 4 plus 1/4, and we end up with 4 1/4. Now, when you draw when you write the equation, it's probably best to write an improper fraction rather than a mixed number. Remember, in algebra, we don't really use improper fractions, we don't use mixed numbers very often. But you kind of have to use them when you graph, because it's difficult to conceptualize the value of improper fractions sometimes. But if you got those answers, good job. And if you want to, teachers really like it when you organize your work, so you can write those as part 1 and part 2. Okay, so try number 4, and when you come back, we'll do it together. All right, we're back. It says, graph the following quadratic expression, write the coordinates of the vertex and 2 other points. So it's pretty much the same problem. We need to graph this. The graph is going to be a parabola. The graphs of quadratic expressions are always parabolas. And so the most important point that we need to find is the vertex. Remember, that's always the most important point of a parabola. So in order to do that, we need to identify what form this equation is in, and we can see it's in standard form. And A is 2, B is 20, and C is 50. So that's going to help us analyze this parabola. You need to remember that the x value of the vertex in standard form, this only works for standard form. This equation only works when your equation is in standard form. Extremely important to understand. So it's negative b over 2a. So b is 20, a is 2. So if you do the math, you end up with negative 5. 20 divided by 4 is 5, and the negative just hangs out there. So the x value of the vertex is negative 5. So now we're going to find the y value, and you might wonder, well, why am I writing these squiggly lines? Do you have to do that on the test? Well, you could probably get away with not doing it on the test, but it helps to kind of organize your thoughts. I'm doing this, and then I'm going on to the next thought, and I'm going on to the next thought. So it helps organize your work. In class, I actually gave a title for each one of these steps. The problem is that's going to take a long time on the test. You don't really have to do that. That would take a lot of your energy. It's not really about time. It's mostly about conserving energy. When you're taking a test, you really have to be careful to conserve your energy. So now we're going to use this equation to find the y value of the vertex. We're going to plug in -5 for x. And so we get, I don't have a lot of room here to write, so I'm going to probably do a lot of these steps in my head. -5 squared is 25. 20 times -5 is -100. And so the y value of the vertex is 50 minus 100, which is -50, plus 50 is 0. So we're kind of out of room there. So I'm going to move this down one line. That's the benefit of having a digital notebook. The vertex is -5, 0. So I've got that on the graph there, -5, 0. So this is the case where the vertex is actually on the x-axis, which means there's only going to be one x-intercept. So it says, write the coordinates of the vertex and 2 other points, one on each side of the line of symmetry. So we have to find some other points. Now, you don't have to show the math when you plug in x values here. We're going to plug in some x values around the vertex. Now, my advice is don't choose, for example, 0 for x. If you choose 0 for x, what's the problem? Well, these two terms are going to go away, and what are you going to be left with? 50. Well, there's no way you're going to be able to graph 0, 50 on this. It's way up here. So you want to plug in x values that are around the x value of the vertex. So the x value of the vertex is -5. You can plug in probably -4. And you don't have to show this on paper. You can do it in your head. So -4 squared is 16. 16 times 2 is 32. So maybe write down 32 so we don't forget that. You don't have to write it down, but it'll help you not to forget. And -4 times 20 is -80. So we have 32 minus 80, which is -48. And -48 plus 50 is 2. So if you plug in -4, you get 2. Let me plot that point. And we can use symmetry. Remember, here's your line of symmetry. We can go straight across to find another point. And then we can just connect the dots. And let's write the coordinates on the graph. It doesn't tell you that you have to do that, but it's probably best that we do it on the graph. We do have to write the coordinates somewhere. So it might as well be on the graph in this case. And we have -6, 2. So you can draw little lines that go to those points, maybe to help. So if you got that right, excellent. All right, on to number 5. Try number 5. When you come back, we'll do it together. Okay, we're back. It says find the coordinates of the focus and the equation of the directrix in problem number 4 and draw them on the graph. Use a dotted line for the directrix. So this is kind of the same problem that we just did, but the difference is it's actually telling us to write these things on the graph. So be aware of that. You really have to follow directions. It says draw them on the graph. So we got to go back to the previous graph and draw them on that. If you don't do that, you're going to lose points. So again, the x value of the focus is the x value of the vertex, and the y value of the focus is the y value of the vertex plus p. You must remember those things on the test. You're not allowed a cheat sheet. You have to remember those things. The equation of the directrix is y is equal to the y value of the vertex minus p. So the x value of the focus, or the x value of the vertex, that is -5. We can see that up there. The y value of the vertex is 0, and we have to find p. But so we're stuck. We don't know what p is. So really, the first part of this problem is to find p. And you need to remember that p is equal to 1 over 4a. That's one of the most important equations in this part of the course, in the entire course, really. So now we have to ask the simple question, what is a? Well, a is up here. We wrote a there. Remember, a is always that number that goes in front. It doesn't matter what form of the quadratic we're talking about. A is always that number in front. So a is 2 in this case. So we have 1 over 4 times 2, which is 1 over 8. 1 over 8 is kind of a small number, so it makes it difficult for us to work with that number, but sometimes you just have to work with the difficult numbers in math. So those are the coordinates of the focus, and we're going to write those coordinates on the graph. We'll do that later, but we can't forget. Don't forget to do that. Let's divide our work here. The y value of the vertex is 0, and p, as we just found, is 1/8. So the equation of the directrix is y is equal to -1/8. So now we have to go up to, and we could rectangle this, these, just to kind of show that that's what the point of the problem was, but we do have to go up to the graph and make sure to write these coordinates in. So I'm going to write the focus with orange color. You don't need colors. -5 and 1/8. So that's going to be very, very close to the vertex. Almost, it's going to seem to almost touch the vertex. I'm going to make the vertex smaller. It's kind of hard to get in there, but that's okay. It doesn't have to be perfect. And again, you don't have to use colors. Okay, so we have -5, 1/8. Those are the coordinates of the focus. And the directrix is y is equal to -1/8. So I'm going to draw that as a dotted line. That's pretty close to the x-axis. I know it's kind of hard to draw these things when they're so close. I'm going to use a smaller pen. So it's very, very close, and it's kind of hard to see if you make it exactly 1/8 distance. But the equation is y is equal to -1/8. So it might be kind of hard to see that, but that's okay. You can't help that it's hard to see. Just make sure that you draw that. And there we go. We are done with problem number 5. If you got that right, good. If you got stuck, that's okay. It's perfectly fine to get stuck. We're reviewing, and this is giving you, again, valuable information. It's telling you the things that you need to study. Okay, try number 6, and when you come back, we'll do it together. Okay, we're back. So this looks like kind of the same type of problem that we did in problems 1 through 5. And remember, if you're going to graph a quadratic equation or expression, whatever you want to call it, the most important point is the vertex. So we have to find the vertex, but it's useful for us to obviously remember the forms of of a quadratic expression. You need to remember the 3 forms. If you don't remember those 3 forms, then there's no way you're going to pass this test. A, we can see, is 1 because there's nothing there. It means it must be 1. H is -2. It's always going to be the opposite sign. I know that's hard to remember, but it's always going to be the opposite sign. it's positive 2 here, but it becomes negative 2. And then this number, that's going to be, the sign is not going to be opposite. It's just whatever that number is. Again, I know that's hard to remember that, but you're just going to have to remember it anyway. So let's see. Now we have that information. So now we need to remember that the vertex is just h comma k. That's why this is called vertex form, is we can see the vertex just by looking at it. It's negative 2, negative 2. So let's plot that. And as you can see, we're almost done with the problem. We just need 2 more points around the line of symmetry. So maybe we can choose 0. In fact, yes, in this case we can choose 0 for x. So if x is 0, 0 plus 2 is 2. 2 squared is 4. 4 minus 2 is 2. So 0, 2 is another point. And we can use symmetry to go straight across. Remember, the distance from the line of symmetry to that point is the same distance from the line of symmetry to the other point on the other side, or the corresponding point. Now, we could try to plug in another x value to make our graph a little more accurate, but it doesn't really tell you to do that, so you don't have to do that. Your graph doesn't have to be perfect. This is not an art class. Don't waste a lot of time trying to make your graph completely perfect. Okay, so we need to put these points on the graph. It doesn't actually tell us to do that in this problem, but we haven't written the coordinates of these points yet, so we might as well do it on the graph. So there you go. If you use those points, good. Now, you don't have to use those points. I forgot to mention in the previous problems, you could use other points. For example, I think there's some points up here that you could use. And you may even choose some points that have fractions in them. But as long as your parabola looks like this and those points are actually on the parabola, then you did the problem correctly. So if you got that right, good job. Okay, on to number 7. Now, again, be careful to read the directions. It says find the coordinates of the vertex, which we did in the previous problems, but it says find the y-intercept. Now it specifically tells us to find the y-intercept. You have to find that y-intercept, and it specifically tells us to find the x-intercepts. So we need those points. So try number 7. When you come back, we'll do it together. Okay, we're back. So again, the most important point to find is the vertex, and notice I'm writing vertex form. You don't have to write this. I'm just doing that so we can see what's going on here. So a is negative 1/4. H is 4 and k is 1. And just like we did in the previous problem, the vertex is found with h comma k, and so we have h is 4 and k is 1. So the vertex is 4, 1. That's the power of the vertex form of a quadratic expression. We can see the vertex just by looking at it. So now we have to find the y-intercept and the x-intercepts. To find the y-intercept, we let x equal 0. So we're going to let x equal 0. So we have y is equal to negative 1/4. And you don't have to show this if you don't want. Negative 4, 0 minus 4 is negative 4. Negative 4 squared is 16. 16 times negative 1/4 is negative 4. Negative 4 plus 1 is negative 3. Now you can do that. You can do that on paper if you want, but if you can do it in your head, it's a lot faster. If you want to do that on paper, that's completely fine. But you don't have to. So 0, -3 is the y-intercept. So we found the y-intercept. Now we have to find the x-intercepts. To let the x-intercepts, we let y equal 0. So we set y equal to 0. Maybe I'll show that we're letting y equal 0. So 0 is equal to -1/4 x -4 squared plus 1. Let's make sure we got that equation right. So we just rewrote this equation and we let y equal 0. And if we solve, we find the x-intercepts. So I'm going to subtract 1 from both sides. Multiply both sides by -4. That's the easiest way to do it. And we get 4 is equal to x -4 squared. Then you want to square root both sides. But when you square root both sides, one of the biggest mistakes that students make is they forget to write plus or minus. There's two solutions. Whenever you square root both sides of an equation, you have to write plus or minus. And notice that I didn't show the square root symbols. In class, I showed the symbols, but on the test, you really don't have the energy and the time to do that. You need to show some work, but you can't show every detail. That's beginning algebra stuff. You don't really have to show it. So now, +2 is equal to x -4, or -2 is equal to x -4. So x is 6, or x is 2. So we found the x-intercepts. So 6, 1, 2, 3, 4, 5, 6, and 2, 1, 2. And let's connect the dots, and we could find maybe another point down there somewhere, but again, the problem doesn't ask us to find any more points, so we have the accuracy that is required in the problem. So the vertex is 4, 1, and I'd like you to write a V next to your vertex. I forgot to do that in the previous problems. Let's go ahead and write V. V for vertex. Sorry, I forgot to do that. You're probably not going to be required to do that in school, but it's good to do so we can see that we're talking about the vertex. And this point here is 2, 0, and this point is +6, 0. Those are the x-intercepts, and we have the y-intercept, which is 0, -3. So if you got that one right, excellent. That was problem number 7. Now problem number 8 is asking you to do things related to problem number 7, so go ahead and try number 8, and when you come back, we'll do it together. Okay, we're back. Also, be aware you need to draw these coordinates on the graph. It says specifically draw them on the graph. So we're going to draw the directrix of the parabola on problem number 7 and write its equation. So let's start by writing its equation. Remember, you have to remember the equation of the directrix is y is equal to vy minus p. So right away we have a problem because we don't know what p is. So p is really the first part of the problem. We need to find p. To do that, we need to know a, and remember, a is always the first constant regardless of what form you're using, vertex form, intercept, or standard. So we know that a is -1/4. So we can plug in -1/4, and we get -1 for p. Okay, so now that we have p, we can find the equation of the directrix the y value of the vertex we found is 1, and p we just found is -1. So that's double negative, it becomes positive, so we have y is equal to 2. That's the equation of the directrix. So we can draw that on the graph, y equals 2, because it says draw the directrix on the graph. So y equals 2 is going to be up here. It's kind of a thick line there. And you might have to erase the coordinates of the vertex or just write them lower. That's okay. Sometimes that happens. Don't be frustrated by that. Sometimes you have to erase and rewrite things so you can fit everything on the graph. I know it's kind of frustrating to do that, but so we have the directrix drawn, and we should probably draw the or write the equation on the graph. It doesn't say that to do that specifically, to write the equation on the graph, but you should probably do that. Okay, if you got number 8 right, good job. Go on to number 9, and when you come back, we'll do it together. Okay, we're back. Find the coordinates of the focus and the equation of the line of symmetry of the parabola in problem number 7. Draw them on the graph. Okay, so remember, we have this guideline here. You need to remember that. So to find the x value of the focus, we need the x value of the vertex, which is 4. And the y value of the vertex is 1. And we found p is -1. So most of the work has already been done for us. So 4, 0 is the value of the focus. So I'm going to draw that as an orange dot there. And I'm going to write F for focus. So 4, 0. And I think I forgot to write an F for the other problem. Actually, no, I didn't. I wrote F for focus there. It's good to identify the vertex and the focus with a V or an F. Okay, so we found the coordinates of the focus, the equation of the line of symmetry, and that was part 1 of that problem. Now part 2 is to find the equation of the line of symmetry, which is just x is equal to vx, and vx is the x value of the vertex, which is 4, so there you go. We have the equation, so now we just have to draw it in. And I guess we can just use purple for that. Again, you don't have to use colors. And the equation is x is equal to 4. So if you have this all drawn on the graph, and you got those equations and coordinates right, good job. So we found the coordinates of the focus in the equation of the line of symmetry, and we drew them on the graph. So just go back and make sure that you followed all those directions. Students typically lose a lot of points just because they're not following directions in school. And like I said, teachers just love to take off points because you're not following directions. They really enjoy doing that. So now try number 10. And again, if you get stuck, that's okay, but try number 10. When you come back, we'll do it together. Okay, we're back. It says graph the following quadratic expression, write the coordinates of the vertex and the x-intercept. So again, we have specific information that we're supposed to find here. Specific things we're supposed to do. You got to read the directions properly. Really important to read the directions properly in this particular test. But that's true of all tests. Okay, so this is standard form. So we know that A is -3, we know that B is -8, and we know that C is -4. Now, there's a lot of different ways to do this. A lot of different ways. Let's see. It turns out that this problem can actually be factored, but it's probably easier just to use our formula for the standard form of a quadratic expression. So that's the x value of the vertex. B is -8, and A is -3. So we have 8 over -6, which simplifies to -4 over 3. So let me move this over a little bit. -4 over 3. And it's probably best to write that as a mixed number. -1 and 1/3. For graphing purposes. But when you plug that into the equation to find the y value of the vertex, you want to use the improper fraction form because improper fractions are easier to deal with in terms of the calculations. So -3 times -4 squared. We're plugging in the x value of the vertex, which is -4. We just found that. We're writing it in improper fraction form. That's this yellow form here. And I know what you're thinking. You're thinking that this is horrible. Why do we have to plug in a fraction? This is a lot of math, and we don't like having to do this. It's tedious. But sometimes you just have to do it. You can't avoid fractions in mathematics. So just buckle down and just get it done, and get it done fast. So -4 over 3 squared is 16 over 9. We have a double negative, so that, or a negative times a negative, so that becomes positive 32 over 3. And continuing the math, we have -3 times 16 is -48. Multiply both sides of this fraction by 3, and we get 96 over 9. And if you consider 4 to be 4 over 1, multiply both sides of that fraction by 9, and we get 36 over 9. So now we have a common denominator. -48 plus 96 is 48. 48 minus 36 is 12. So we have 12 over 9, which simplifies to 4 over 3. And for graphing purposes, we can change that to 1 and 1/3. So now we know the vertex. We did all that work just to find the vertex. And again, I know what you're thinking. You're thinking that was horrible. We had to do all that work, and that was a lot of work. But again, sometimes you just have to do that. And keep in mind, you don't have to show all of that. You can do a lot of that in your head. You can skip a lot of those steps. The most important thing is to show that you're plugging in -4/3. Okay, so now we can draw the vertex. The vertex is -1 and 1/3 and +1 and 1/3, which would make the vertex about there, roughly. It doesn't have to be exact, but right about there. Okay, so now we're supposed to find the x-intercepts, and let's write the coordinates of that vertex before we forget. So that's -1 and 1/3, comma 1 and 1/3. So we need to find the coordinates of the x-intercepts. So in order to do that, we let y equal 0. So if you do that in that equation, actually that should be -4. let y equals 0, you get that equation there. So we just rewrote the original equation, except we're letting y equal 0. Now there's a lot of different ways to do this. You could complete the square, but you never really want to do that unless you're forced to do it. There's nothing in this problem that tells us we have to complete the square. Completing the square takes forever. So we could use the quadratic formula. But in this particular problem, it turns out that we can actually factor this. If you multiply both sides of the equation by -1, you get 3x squared plus 8x plus 4. It's perfectly legal to do that. And so now you can factor it. Now again, you could use the quadratic formula, but I'm just showing you that sometimes you can factor these things. What two numbers multiply to 3 while 3 times 1 works? So let's try positive 2 and positive 2. And let's FOIL. So f of FOIL is 3x times x is 3x squared. We're checking to make sure this works by multiplying back, going the opposite direction. That's f of FOIL is 3x squared. O of FOIL is outside terms, 3x times 2x. So that is 6x. And I of FOIL is 2 times x. That's the inside terms. That's 2x. And then L of FOIL, the last terms, 2 times 2 is 4. So now we have 3x squared plus 8x plus 4. So it looks like I got lucky. 2 times 2 would work, but 1 times 4 could also work. But it turns out that 2 times 2 was the right choice. So now this helps us to find the x-intercepts. We know that one x-intercept is -2 because you plug that in here, you get 0. So x plus 2 could be 0, which means that x is equal to -2. Or 3x plus 2 could be equal to 0, which means that x is equal to -2/3. So we found the x-intercepts. Now again, I'm explaining this, so it's taking a lot longer to do the problem, but you don't have to explain anything on the test. You just have to show the work, some of the work, not all of it. You don't have to show every single step, but you have to show roughly how you got those x-intercepts. So -2 is an x-intercept, and -2/3 is an x-intercept. And if we don't have to really show any other coordinates, but if we plug in 0 for x, we can see up here we get -4. So that'll help us graph, and we can use symmetry. Actually, it's not very easy to use symmetry in this case, but we can try. So it looks something like that. So that's good enough. So this point here is that's -2, 0. That's one of the x-intercepts, and this point is -2/3, 0. That's the other x-intercept. So that's all the problem really asks us to do, is find the x-intercepts and the vertex. But you can see with that problem there was a lot of work because we had fractions and we had to solve a quadratic equation. Again, there's a lot of different ways to do that. You can use the quadratic formula, x equals -b plus or minus root b squared minus 4ac over 2a, which we're going to need to do in other problems in this test. But with this problem, we could factor to find the x-intercepts. So if you got those answers, good job. Okay, try number 11, and when you come back, we'll do it together. Okay, we're back. It says draw the line of symmetry of the parabola in problem number 10 on the graph and write its equation. So that's going to be pretty easy. The line of symmetry, or the equation of the line of symmetry, is just x is equal to vx, meaning the x value of the vertex. So x is equal to whatever the x value of the vertex is, and that is -1 1/3. So we wrote its equation, but it says specifically to draw the line on the graph, so we need to do that. So I'm drawing it as a dotted line, just as it says there. Actually, it doesn't say to draw it as a dotted line, but we should do that. And we're going to write the equation on the graph. It's always best to write the equation on the graph. So there we go. So that was kind of an easy problem. Number 12, go ahead and try number 12. If you got 11 right, good job. Attempt number 12. When you come back, we'll do it together. Okay, we're back. What is the y-intercept of the graph in problem number 10? So it turns out we actually figured that out already. That's this point here. So that is 0, -4. And we found that just by plugging in 0 here for x. And remember, when you're in standard form, this constant up here, you see that yellow constant up there? That's always the y-intercept of the parabola if you're in standard form. It only works if you're in standard form, ax squared plus bx plus c equals y. So we can just write that 0, -4. We could show some work there, but there really is no work to be shown. We were given an equation that told us, or we were told that that constant is always the y-intercept. So if you got those right, good job. Go ahead and try number 13. And when you come back, we'll do it together. Okay, we're back. It says find the discriminant of the quadratic expression below and use it to determine the number of x-intercepts of the corresponding graph. So first of all, we need to identify the constants. Now, we can only find the discriminant of a quadratic equation if it's in standard form. If it's in some other form, we don't really have a simple equation to help us do that. So a is equal to 10, b is equal to -3, and c is equal to 1. So the discriminant is b squared minus 4ac. So how are we going to remember that? Well, remember, the quadratic formula tells us to find, or it helps us, it tells us exactly what the solutions are of any quadratic equation that's in standard form. So x is equal to -b plus or minus root b squared minus 4ac all over 2a. And notice that this part inside the root is the discriminant. So if you know the quadratic formula, which you should not take this test unless you know the quadratic formula, then you also know the discriminant because that's just the part inside the root. And so let's plug in our values. B is -3. A is 10 and C is 1. Now we just have to do the math. So -3 squared is 9. -4 times 10 is -40. And -40 times 1 is -40. So we have 9 minus 40, which is equal to -31. So that is the discriminant. They ask us to find the discriminant, so we did that. But they also want us to use the discriminant to figure out how many x-intercepts the parabola of this equation has. The discriminant is negative. That means that there are no x-intercepts. So what that means is that your parabola doesn't go through the x-axis. So it might look like this, or it might look like this, or it might look like this. It doesn't go through the x-axis. So there are no x-intercepts. Because if you try to solve a quadratic equation and you use the quadratic formula, the formula tells us that if b squared minus 4ac is negative, then that means that the solutions to the quadratic equation are going to be imaginary. A quadratic equation is the equation that results when you allow y to be 0. If you want to find the x-intercepts, you let y equal 0. If you solve that equation when y equals 0, you get this formula. But if the inside part is negative, then you get a complex solutions, two complex solutions, which means that there are no solutions, at least that are not real. So there are no x-intercepts. Now, if this discriminant were positive, that would mean you would have two real solutions because you have the plus or minus there. If it's negative, you have two complex solutions because, again, you have the plus or minus. But if this discriminant is 0, then you have a real solution because the square root of 0 is a real number. But the plus or minus goes away. So you only have one real solution because the plus or minus in front of that root goes away. I know that's kind of confusing to consider all that, but it'll help you remember. Okay, so if you got that one right, excellent. On to number 14, it says write an equation of the parabola, and it says hint, it's easiest to use vertex form. So be sure to use vertex form. And I already have that written here, but go ahead and write it out yourself. Try number 14, and when you come back, we'll do it together. Okay, we're back. So I already had vertex form written there. And what we do is we plug in a y value of a point. Now, we can't use the vertex for the y value and the x value because the vertex is going to be plugged in for h and k. So we have to use a different point. But luckily, we have a point here. That's -1, -1, 6. So the vertex is, well, first of all, the point is -1, 6, but the vertex is -4, 3. So we can use those 2 points. So I'm going to plug in 6 for y, and a we don't know. That's the only thing that we don't know. I'm going to plug in -1 for x, and for h I'm going to plug in -4, and for k I'm going to plug in 3. So just to be clear, I want to show you where we got all that stuff because it can get kind of confusing. Again, you don't have to use colors in your on your test. This is just to help us practice. So now all we have to do is solve that equation. We have a double negative, so that becomes -1 plus 4. -1 plus 4 is 3. And all we have to do is solve this equation. Remember to use order of operations. Do what's inside the parentheses first, then do the exponents. Subtract 3 from both sides, and we get 3 is equal to 9a. Divide both sides by 9, and we have a is equal to 1/3. So at that point, we're pretty much almost done. Now we just have to write the equation. So y is equal to a, which we just found is 1/3, times x minus the x value of the vertex, which we know is -4. We found the x value of the vertex. That's that purple number up there. And Then we need plus k, and k is 3. It's that yellow number up there. So now we can simplify. That double negative becomes x plus 4 squared plus 3, and that is the solution. So you don't have to show all of this stuff up here. I would like you to show this math here. You do have to show something. But if you got that answer, excellent. Very good. Okay, try problem 15, and when you come back, we'll do it together. Okay, we're back. So it says, for each problem below, write an equation of the parabola with the given characteristics. It's easiest to use vertex form, it says. Assume that all corresponding parabolas open up or down, meaning like the parabolas we studied in the course. There are parabolas that open to the left or to the right, but we didn't cover those in this course. Okay, so if we're given the vertex, we know h and k, and if we're given the y-intercept, we have a point, 0, -10. If they say that the y-intercept is -10, then that means that there's a point on the graph that is 0, -10. Remember, the x value of the y-intercept is always 0. If you're trying to find the y-intercept, you let x equal 0. If you're trying to find the x-intercepts, you let y equal 0. So that can be kind of confusing for a lot of students. They don't get past that step. But you can see it's pretty easy. If you have practice with these problems, you're going to be able to do these pretty quickly. So now let's write the vertex form, because the problem gave us a hint. It told us vertex form is easiest to use. The y value of our point is going to be -10. So that's where I'm getting that. A is the only value that we don't know. X is going to be 0, so I'm getting that from there. And h is 2. I'm getting that from there. Don't forget to square it. A lot of students forget to square. And k is 5. I'm getting that from there. So now we just have to solve that equation for a. And once we have a, then we'll have everything that we need to write the equation. So -2 squared is 4. Subtract 5 from both sides. Divide both sides by 4, and we see that a is -15/4. And you can just leave that as an improper fraction. So now that we have a, we can just write the equation. Y is equal to a, which is -15/4, times x minus the x value of the vertex, which is 2. So I got that from there. Plus k, which is 5. And there you go. That's the equation. So if you got that answer, excellent. Good job. Okay, so again, it says for each problem below, write an equation of the parabola. So we're looking for an equation of the parabola and use vertex form. That's this form here. So try number 16 at the bottom left. 16 is going to be a little harder, in fact a lot harder, because we're not given the vertex. We're not even given a point on the parabola, so how in the world do we do this? Well, it's more challenging. So try number 16. When you come back, we'll do it together. Okay, we're back. So remember, the coordinates of the focus are Vx, Vy plus P. And the equation of the directrix is y is equal to Vy minus P. So this information is really going to help us. So we know that the coordinates of the focus, well, we don't really need to know. We don't need Vx now. We just need this information. We need to focus on the y value of the vertex. So, or excuse me, the y value of the focus. So the y value of the focus, we know what that is. We know that this yellow has to be equal to -4 3/4. That's the y value of the focus. So we know that -4 3/4 is equal to Vy plus P. Now we don't know the y value of the vertex. We know that the equation of the directrix is y is equal to -5 1/4. But we're told you find that equation with this information here. So what that means is we can plug in -5 1/4 for y, and we get this equation here. So now what we do is we take these two equations and put them together to make a system of equations. And I know that's pretty scary to have to solve a system of equations, but this system is actually going to be pretty easy, so we don't really have to do a lot of math to solve it. So I'm going to put some brackets there to show that we're putting those two equations together. And we're going to solve this system to find the y value of the vertex, because we already know the x value of the vertex. It's up here. It's the x value of the focus. And we're going to find P and we're going to find Vy. We have to find both of those to find the equation of the parabola. But notice that we have P and -P. That means that we can use elimination. We can go ahead and add these equations up. So P plus -P is 0. Those cancel out. Those eliminate. Vy plus Vy is 2Vy. And you can do this in your head. I know that seems kind of complicated, but that's pretty easy. -4 plus -5 is -9. And -3/4 plus -1/4 is -1. So we have -9 plus -1 is -10. So adding those up, we get -10. You can do that however you want. Divide both sides by 2, and we get -5 is equal to Vy. So now we have the y value of the vertex. We need to find the x value of the vertex. We need to find P. So we can take one of these equations aside. We have -4 3/4 is equal to the y value of the vertex, which is -5, plus P. So add 5 to both sides, and we get 1/4 for P. So now we have the y value of the vertex and P. And so we can now use P to find A. And once we find A, we're going to have pretty much everything that we need. So P is 1/4. And notice how I'm dividing all this work up. And we don't really even have to do much to this. We can see that A has to be 1. There's no way this equation could possibly be true unless A were 1. But if you want to solve algebraically, you would just multiply both sides by 4A. And we would get A is equal to 1. Actually, if you did it that way, you would end up with A is equal to 1 with A on the left side. So the x value of the vertex is the x value of the focus. You don't really have to write this, and the x value of the focus is, we see up there, is 4. So the vertex is 4, -5. So I got that -5 from there, and I got the 4 from there. And we found a is 1, so now we're ready to write the equation. Y is equal to a, which is 1, so we don't really have to write anything, minus h, which is 4, squared, plus k, which is negative 5. If you add negative 5, you can just write it as minus 5. So that is the final answer. If you got that equation, good job. Okay, so that was kind of a challenge problem. Go on to number 7 and see if you can do 17, that is, and when you come back, we'll do it together. Okay, so this is vertex form. To convert to intercept form, we have to first convert to standard form. So the way that we do that is we do what's called expanding the exponential expression. Remember, when you raise something to the second power, that means you multiply whatever the base is by itself. So x minus 6 times itself, x minus 6. And to do that, you have to use FOIL because we're multiplying two binomials. A binomial times a binomial. So this negative is just going to hang out in front there. X times x is x squared. X times negative 6 is negative 6x. Negative 6 times x is negative 6x. Negative 6 times negative 6 is positive 36. That's the operation. It's called FOIL. It's an acronym for first terms, outside terms, inside terms, last terms. Now, we can't forget that negative there. We have to distribute that negative to each one of these terms. But before we do that, let's combine the like terms. So negative 6 minus negative 6 is negative 12. And of course, we have the x that goes along with it. So now we're going to distribute that negative. Consider this to be like negative 1. So we have negative x squared plus 12x minus 36. Now, don't put the negative on the 9. The 9 has nothing to do with that negative. We're not multiplying 9 by negative 1, only what's inside the parentheses. These little details are what makes a difference between a student who's fluent in mathematics and a student who is not fluent in mathematics. How do you become fluent? You study for the test and do practice problems. That's the only way to do it. So now we're going to combine negative 36 and 9, and we get negative 27. So we have not accomplished our goal yet. We have not accomplished our goal. All we've done is converted to standard form. But that's going to help us convert to intercept form. So what we're going to do is factor out a negative 1, because remember, it's very difficult to factor a quadratic expression if the leading coefficient is a negative. You can do it, but I don't really recommend it. And now we're going to factor, and I specifically designed these problems so that you can factor these fairly easily. So what two numbers multiply to 27? Two numbers multiply together to get 27, but if you add those same two numbers, you get negative 12. So what are two numbers multiplied together that get you 27, but if you add those two numbers together, you get negative 12? Well, if you said negative 9 and negative 3, you're correct. Negative times a negative is a positive, and a negative plus a negative is a negative. So we are done. That is intercept form. Why is it called intercept form? Because we can see the x-intercepts just by looking at it. 9 and 3. All right, if you got that one right, good job. So if you can do that, you can convert from vertex form to standard form, which we got down here, and you can convert to intercept form. Problem number 18, we're doing the same thing, except now we're converting from intercept form to vertex form, so we're actually going backwards. Now, you can complete the square, or you can use other methods we'll talk about, but see if you can do number 18. If you get stuck, that's okay, but try number 18. When you come back, we'll do it together. Okay, we're back, so we're going to multiply these two binomials together. So x times x is x squared, x times 5 is 5x, negative 1 times x is negative x, and negative 1 times 5 is negative 5. We used FOIL to multiply those two binomials, F-O-I-L, first terms, outside terms, inside terms, last terms. So first terms, outside terms, multiply inside terms, multiply last terms. So now we're going to combine like terms. 5x minus x is 4x. And then we're going to distribute the 2. And now we are in standard form. Now what we could do is complete the square, but that takes a long time. The easiest way to do it really is to find m and n. That's in intercept form, so we know m is 1, and we know m is negative 5. Then you can find the x value of the vertex by using the formula m plus n over 2. Once you find the x value of the vertex, plug it back into this equation and find the y value of the vertex. Now listen very carefully. If you have the x value and the y value of the vertex, so you have the coordinates of the vertex, and you also have a, because remember, a is always that number in front, regardless of whatever form you're in, vertex, intercept, or standard form, then you have everything that you need. So that's probably the easiest way to do this problem. But we're going to complete the square also, just to show you that completing the square is another way that you can do it. So I'm going to divide both sides of the equation by 2. And I'm going to put the 5 on the other side. And you don't have to do this, but you can. I'm just going to rewrite all that just so you can see that we're going on to the next step when we complete the square. I'm going to complete the square, but I have to know which number completes completes the square for this expression. Remember, you always take this number next to x, the coefficient of x, not the coefficient of x squared. You take the coefficient of x and you do two things to it. You divide by 2 and you square it. So you take this number, divide by 2, and you get 2. Then you take that number, 2, and you square it. So that means that 4, because 2 squared is 4, that's going to be the special number that's going to complete the square. So what does that mean? Well, first of all, we can combine these numbers. 5 plus 4 is 9, so we combine those. But it means that if you factor this expression, if you ask what two numbers multiply to 4 and add up to 4, and factor that, these two factors are going to be exactly the same. That's what it means to complete the square. Those factors are exactly the same, which means that you can write those factors in exponential form. So why did we do all that? What was the point? Well, the point is we're very close to vertex form. We're going to subtract 9 from both sides. Then we're going to multiply both sides by 2. Now, when students do this, they oftentimes only multiply one of the numbers. They only multiply 9, or they only multiply the x plus 2 squared. You got to multiply both of them. You got to use the distribution rule. So that is the final solution. We converted from intercept form to vertex form, but we had to first convert to standard form. Alright, so if you got that right, good job. On to number 19. Whoops, forgot to erase that. Go ahead and attempt number 19. It says specifically to find the other two forms, intercept and vertex form. So try 19. When you come back, we'll do it together. Okay, we're back. So I'm going to do, in the previous problem, I completed the square to write in vertex form, but I'm not going to do that in this case. I'm going to choose the easier method. So the easier method, well, first of all, we're in standard form. So what that means is we know what A is. A is equal to -3. We also know B and C, obviously. I don't think we'll need C, but we will need B, because the x value of the vertex is -b over 2a, assuming that you're in standard form. So B is 6, and A is -3. And so 1 is the x value of the vertex. So now we can plug in 1 to find the y value of the vertex. So we have -3 times 1 squared plus 6 times 1 plus 24. And we get 1 squared is 1. And doing the math, you don't have to show every one of these steps. So we have -3 plus 6 is 3. 3 plus 24 is 27. So that's the x value of the vertex, which means that the coordinates of the vertex are 1, 27. So at this point, we can actually write the vertex form. The vertex form of the equation, because we have the vertex and we have A. We had A from the very beginning. A was this yellow number, -3. Remember, A is always that number in front, regardless of what form of the quadratic you're using. So y is equal to A, which is -3, times x minus h, h is 1, plus, and don't forget to square it. So the 27 came from there, and the 1 came from there, and the -3 came from up there. So that is your answer. So if you got that one right, excellent. Now, oh, whoops, we still have to find the intercept form. See, it's very easy to go too fast and forget to do all parts of the problem. So for intercept form, we're going to take this equation. I'm going to rewrite it. You don't have to rewrite it, but I'm going to do that. I'm going to factor -3. And I specifically wrote these problems so that they can be easily factored. And why does that work? Well, because if you multiply -3 back, you get -3x squared, 6x, and 24. If you go in the backwards direction. So now I'm going to factor that quadratic expression that's in standard form. What two numbers multiply together to get -8 and add up to get -2? The reason that works is because there's no coefficient on the x squared anymore. That's why I factored out that -3. And the answer is -4 and +2. So that is intercept form. So there you go. So if you got those answers, excellent. Okay, on to number 20. Go ahead and try number 20. When you come back, we'll do it together. Okay, let's try number 20. Now this equation doesn't seem to be in really any form. One thing that you could do is distribute, and then it would technically be in standard form, but probably the easiest way to do it is change x to x minus 0. And now we're in intercept form. It's perfectly legal to change x to x minus 0. It's the same thing. And now that we do that, we can see we're in standard form. Or excuse me, we're in intercept form. So we can identify the constants. A is 1/2, m is 0, and n is -4. We can find the x value of the vertex using our special equation. So we have 0 plus -4 divided by 2 is equal to -2. And to find the y value of the vertex, we just plug into our original equation. So we have 1/2 times -2 times -2 plus 4, which simplifies to -2. I'm just debating with myself whether or not I should show that. So we have the coordinates of the vertex, -2, -2. We also need the y-intercept. That should be pretty easy to find. Just let x equal 0. But if you do that, we can see pretty obviously that, that the y value is going to be 0 also. So we have the vertex and the y-intercept. And now we need to find the focus. Remember, we have this useful expression to help us find the coordinates of the focus. The x value of the focus is the x value of the vertex. The y value of the focus is the y value of the vertex plus p. Problem is we don't know what p is. So we need to move this down and first find p. So p is equal to 1 over 4a. And we see here in intercept form that a is 1/2. So we can just plug that in. We have 1 over 4 times 1/2, which is equal to 1 over 2 if you simplify. So now we can use our expression for the focus. P is 1/2, so I'll plug that in there. So the coordinates of the focus are -2, comma, -1, and 1/2. And let's go ahead and graph that. -2, -1, and 1/2 would be about there. So we have that point for the focus. And we'll write the coordinates on the graph a little later. It says draw the directrix, so we do need the directrix, and it says write its equation also. So let's rectangle that. And the equation of the directrix is y is equal to vy minus p. The y value of the vertex is -2, and p we found is 1/2. So our equation should be -2 and 1/2. So now we just have to draw that. -2 and 1/2 would be about there. So we're drawing our directrix. And we can write its equation. Y is equal to -2 and 1/2. And the focus is, remember to write an F for focus, -2, comma, -1 1/2. And the vertex is -2, -2. So a lot of stuff to write here. And we can use symmetry to find another reference point. And we could also plug in some other values. For example, we could plug in 2, and then we get 6 times 1 is 6. That helps us. So we have that point there. You don't have to do that, but I'm just going to do it because it helps me see where the graph is. The problem doesn't really tell us you have to find more points than we found. So there you go. Now let's make sure we follow the directions. We found the coordinates of the vertex. Actually, we haven't written the coordinates of the y-intercept yet. So see, that helps to go back and look at the directions, or else you might miss something. And the focus, we have the coordinates of the focus. We drew the directrix and rewrote its equation. So there you go. So if you got that one right, excellent. Okay, so same set of directions for number 21. Go ahead and try number 21, and when you come back, we'll do it together. Okay, we're back. So this equation is in standard form. You don't have to write standard form as I'm doing here, but I just want to recognize what form we're in, so I'm going to write that for our sake. We have our constants. This equation, this test is going to go a lot faster for you because you don't have to write or explain everything that you're doing verbally, like I'm doing here. So the most important point is the vertex, and we have our special equation to find the x value of the vertex. B is 1, and A is -1/8. So we have -1 over -1/4, and doing the math on that, multiply both sides by -4, and you get +4. There's a lot of different ways to simplify this. You could use the old arithmetic way, -1 divided by -1/4. Flip the divisor and change to multiplication, and multiply straight across. 4 times 1 is, or -4 times -1 is +4. A lot of different ways to do that. But again, this is an intermediate algebra course, so that is stuff you really should know. So Vy, the y value of the vertex, we're just going to plug in the x value of the vertex to help us find the y value of the vertex. So plugging in 4, and Vy is equal to -1/8 times 16, plus 4 minus 5 is -1, so we can just write -1. And so we get -3 for the y value of the vertex, which means the vertex is 4, -3. So we have the vertex 1, 2, 3, 4, 1, 2, 3. And what else do we need? We need the y-intercept. So the y-intercept in standard form is always this value here, -5, in this case, because if x is 0, y has to be -5. So we can mark that 1, 2, 3, 4, 5. So that's our y-intercept. And we're also supposed to find the focus and the directrix. We can't do any of those things unless we find P first. And to find P, we plug in A. So we know that A is this value up here, -1/8. So we plug in -1/8. and we get 1 over negative 1/2, which simplifies to negative 2. So now that we have P, we know the coordinates of the focus are Vx, comma, Vy plus P. The x value of the vertex is 4, the y value of the vertex is negative 3, and P is negative 2. So we have 4, comma, negative 5. That's the coordinates of the focus. So now we need to find the equation of the directrix, which is Vy minus P. Y equals Vy minus P. The y value of the vertex is negative 3, and P is negative 2. So we have a double negative. We have negative 3 plus 2, which simplifies to negative 1. So that's the equation of the directrix. So the directrix is going to be a dotted line at y equals negative 1. And the focus is 4, negative 5. Which should be about here. And we can use symmetry. 1, 2, 3, 4. 1, 2, 3, 4 to find another point there. And now we'll connect the dots. We could be more precise by finding some other points, but the problem doesn't ask us to do that. So it looks like we have pretty much everything. Y equals negative 1 is the equation of the directrix. The vertex is 4, comma, negative 3. The y-intercept the y-intercept is 0, negative 5. And the coordinates of the focus are, again, you don't have to use different colors here. 4, negative 5. You can just draw a line showing that it's coming from, it's showing that the coordinates of that point. So if you got that one right, excellent. Very good. Okay, so go ahead and attempt number 22. Number 22 should be a lot easier than 21. And when you come back, we'll do it together. Okay, we're back. Graph the following quadratic expression. Write the coordinates of the vertex, y-intercept, and x-intercept. So this equation looks very easy. You can think of this as standard form. You can think of it as vertex form. Those are two different ways to consider the problem. I'm just going to consider it to be vertex form because that's usually the easiest way to graph a quadratic expression, to have the vertex form. So we know A and H and K and all that. So the vertex is obviously H, comma, K, which is 0, comma, 3. So 0, comma, 3 is the vertex. We already have the vertex. Now, if the vertex is on the y-axis, then that means the vertex is the y-intercept. So we also found the y-intercept. Now, if we're going to find the x-intercepts, we let y be 0. And then we solve. If we solve the equation, we put 3 on the other side, and we multiply both sides by 3, we get negative 9, and immediately something weird is going on here because there's no way that equation can even be solvable. So it looks like there are no x-intercepts. Let's plug in 3 for x. 1, 2, 3. 3 squared is 9. 9 times 1/3 is 3. 3 plus 3 is 6. So if we go out 1, 2, 3, we go up 1, 2, 3, 4, 5, 6. And we can use symmetry. You can see that there are no x-intercepts because the graph goes up like so. So the problem tells us to find the x-intercepts, but it's kind of a trick problem because we can say there are no x-intercepts. Now the question that you're going to ask is, do you have to show this math to prove that there are no x-intercepts? And the answer is not really. You can just plug in x values and you can see that the parabola is not going to go through the x-axis. But you do have to write no x-intercepts because the problem specifically asks us to find the x-intercepts. And you need to show the person who wrote this test that there are no x-intercepts, or you need to tell them that. So it's kind of a trick problem. So we wrote the coordinates of the vertex. Let's write those coordinates on the actual graph. So 0, 3. We found the y-intercept, which is also 0, 3. And there are no x-intercepts. So if you got that one right, excellent. Okay, on to number 23. It says, graph the following quadratic expressions, write the coordinates of the vertex and the x-intercepts on each graph. Write exact expressions for the x-intercepts. So the reason it's saying that is because the x-intercepts are going to be roots. You might get something like root 10 minus 3. So I want you to write the exact expression for that. And you can estimate using just basic logic. For example, if you wanted to find what root 10 is roughly, then you would find root 9, and then you would find root 16, which must be, root 10 must be in between those. Root 9 is 3, root 16 is 4, so root 10 must be somewhere between, and it's going to be closer to 3, obviously, so you can estimate root 10 as like 3.1 or 3.2. That's good enough. So go ahead and try number 23. And when you come back, we'll do it together. Okay, so this is in vertex form. Again, you don't have to write the vertex form. I'm just doing this for our benefit. This test is going to go a lot faster for you because you don't have to write all this. You don't have to write the form and whatnot. So a is 5, h is -3, and k is -10. The vertex in standard form is just h comma k. That's why it's called vertex form. So we have -3, -10 for the vertex, so we can go ahead and plot that. That's all the way down there. So we need the line of symmetry. I can go ahead and draw that before we forget. And we're supposed to write its equation, so I'll go ahead and do that also. So line of symmetry would be x equals -3 because it's x equals the x value of the vertex. So now we have to find the x-intercepts. Now that's going to be the part that's going to be somewhat involved. In order to find the x-intercepts, you have to let y equal 0. So we're going to rewrite this equation, but we're going to let y equal 0. And we're going to solve this equation. And we have an equation with a square, which means we have to isolate the square. We have to get it by itself. It's not by itself because the 5 and the negative 10 are next to it. So I'm going to add 10 to both sides of the equation. Divide both sides by 5. Then I'm going to square root both sides. And remember, one of the biggest mistakes that students make, well, it's not the biggest mistake, but it's the most common mistake that students make, is they forget the plus or minus symbol when you square root both sides of an equation. So what this means is that positive square root 2 is equal to x plus 3, or negative square root 2 is equal to x plus 3. So we subtract 3 from both sides and we get square root 2 minus 3 is equal to x, or negative square root 2 minus 3 is equal to x. Now, it's going to be a problem trying to graph these points. So we're going to have to estimate what they are. Now, square root 2, we know, is between square root 4 and square root 1. We know that. That's what these symbols mean. You don't have to use those symbols, but the square root of 1 is 1, and the square root of 4 is 2. So we know that square root 2 is somewhere between 1 and 2. It's going to be closer to 1 than it is to 2, because square root 2 is closer to square root 1 than it is to square root 4. So we can just estimate square root 2 to be maybe 1.3. It doesn't have to be exact. Our graphs don't have to be that accurate. So if root 2 is 1.3, 1.3 minus 3 is negative 1.7. So negative 1.7 is one of our x-intercepts. Again, if root 2 is approximately 1.3, we have negative 1.3 minus 4, which is negative 4.3. So 1, 2, 3, 4.3 is about there. So we can see that we did it correctly because it looks like our parabola is going to be, it's going to have the right shape. I know it's very difficult to make the part next to the vertex rounded, but try your best to do that. We don't want a pointed end at the bottom of the parabola. So I'm going to rewrite my equation for the line of symmetry where we have more room. So let's write the coordinates of the vertex. That is negative 3, negative 10. Again, you don't really have to draw it on the graph unless it tells you. It actually tells you in this problem to draw them on the graph. Now, this is the part where you really have to pay attention here. When we write the coordinates, we have to write the exact coordinates with root symbols. So root 2 minus 3, comma 0 is one x-intercept, and negative root 2 minus 3, comma 0 is the other x-intercept. So you have to write the exact form. Okay, so if you got that right, excellent. Again, you don't really need a calculator, so you can just use this method here to approximate the roots without using a calculator, and you'll be fine. So try number 24, and when you come back, we'll do it together. Okay, we're back. Again, we're finding the vertex and the x-intercepts and the line of symmetry. This is in standard form, unlike the previous problem, which was in vertex form. A is negative 1, B is 2, and C is 6. So the most important point of a parabola is the vertex. In standard form, we can find the x value using this formula. So we have 1. 1 is the x value of the vertex. So now to find the y value of the vertex, we just plug in. So we have negative 1 squared plus 2 times 1 plus 6. So we have negative 1 plus 2 plus 6. Again, you don't have to show every step here. And we end up with 7. So the vertex is 1, comma 7. Let's plot that. So it's right at the top there. And let's see, what else can we do here? It says x-intercepts and draw the line of symmetry. So let's go ahead and draw a line of symmetry. Let's get that out of the way and write its equation. So the equation of the line of symmetry is very easy. It's just x is equal to whatever the x value of the vertex is. So x is equal to 1. And you're going to have to write it next to the line, though, if you're not using colors. And I don't really recommend that you use colors because that's going to take too long to have to switch back and forth. So now we have to find the x-intercepts. When you want to find the x-intercepts of a graph, you let y equal 0, and then you solve for x. The problem is, if we do that, we end up with a quadratic equation, and quadratic equations are not always easy to solve. There are 3 methods. You can complete the square, which you never want to do unless your teacher forces you, because that's the most difficult method. The second thing you can do is use the quadratic formula, which is fairly easy. It looks scary, but it's fairly easy. Or you can factor. Now, if you try to figure out, well, you can multiply everything by negative, because you don't want a coefficient in front of x squared if you're going to try to factor. If you try to figure out what 2 numbers multiply to -6 and add up to -2, you'll find that there really is nothing. Nothing easy. There's no rational numbers. There might be an irrational number. In fact, there are irrational numbers, but there's no rational numbers, meaning there's not going to be any whole numbers or fractions. It's going to be a number with a decimal that goes on forever, is non-repeating. So what that means is we have to use the quadratic formula. So this is a problem where you do have to use that scary formula. And even though it's scary, it's really not hard to use. The most difficult part is that inside part, b squared minus 4ac. So I want you to plug in everything. I want you to show that you're plugging in everything. Before you do any kind of simplification, I want you to plug in all the numbers so that you can show the reader that you know how to use, or at least how to set up the formula. So now that we've got all that plugged in, now we can simplify. So b squared is 4. -4 times -1 is +4. 4 times 6 is 24. 2 times -1 is -2. So let's add 4 and 24, and we get -2 plus or minus root 28 all over -2. And 28 is 4 times 7. 4 comes out as a 2. And let me make some more room here. Then we can divide everything by 2. -2 divided by -2 is +1. Now, when you divide a plus or minus term by a negative, it doesn't really change anything in terms of the signs. But the 2 is obviously going to cancel out. And that's because if you divide a positive by a negative, you get a negative, but a negative is already there. If you divide a negative by a negative, you get a positive, but the positive is already there. So it's still going to be plus or minus. So at this point, we need to approximate root 7. So root 7 is between root 9 and root 4. We're going to need to approximate. So root 9 is 3, root 4 is 2. So root 7 is going to be probably closer to root 9, so we can just approximate it as 2.8 maybe. So 2.8 plus 1 is 3.8. So 1, 2, 3.8 will be about there. And 2.8, 1 minus 2.8 is going to be negative 1.8, which would be about here. So if we did that correctly, our graph should look right. And it looks like our graph does look symmetric. Again, your graph doesn't have to be perfect. So now we have to show the x-intercepts. We have 1 minus root 7, comma 0. And we have 1 plus root 7, comma 0. And the vertex is 1, comma 7. And I think we have everything we need. So if you got those answers, excellent, good job. Okay, we have one more problem. Try number 25, and when you come back, we'll do it together. Okay, we're back. So this is obviously in standard form. You don't have to write ax squared plus bx plus c, but I'm just showing you that we're in standard form. A is 2, b is negative 3, and c is negative 1. Again, you don't have to write that, but you do have to know that in order to do the problem. The x value of the vertex is negative b over 2a. That only works if you're in standard form, obviously. B is negative 3, a is 2. So we get 3 over 4. So that's kind of annoying that we have to have a fraction for the x value of the vertex. But sometimes that just happens. We can't avoid it. So the y value of the vertex is that expression with 3/4 plugged in. So we have 2 times 9 over 16 minus 9 over 4 minus 1. You don't have to show all this. You can do it, a lot of it in your head. Multiply both sides of this fraction by 4, and you get 36 over 16. 1 is the same thing as 16 over 16. Again, that's just basic math. So we have 18 minus 36, which is negative 18. Negative 18 minus 16 is negative 34. Now that's kind of hard to graph that. So we want to change it to a mixed number. So that's 16 is going to go in 2 times with a remainder of 2. 16 times 2 is 32. 34 minus 32 is 2, but we want to reduce that fraction, obviously, so we get negative 2 and 1/8. Now again, I know that's very annoying to have to deal with a fraction like that, but sometimes you just have to deal with fractions. In math class, I can't protect you from fractions. Okay, so 3/4 and negative 2 and 1/8. 3/4 and negative 2 and 1/8 would be about there. And we're supposed to find a y-intercept. So this is in standard form. Y-intercept is just going to be that constant there, negative 1. It's always the third term in the expression if you're in standard form. So we found the vertex and the y-intercept, and we're supposed to find the x-intercepts. In the previous problems, it didn't say to find the y-intercept, but in this problem, it specifically tells us to do that. So all we have to do now is find the x-intercepts. So to do that, we let y be 0. In that equation, and I'm just going to write y is equal to 0 so we know what we're doing. But if you try to factor, we know it's going to be 2x and x, because what two numbers multiply to 2? Well, just 1 and 2. But if you try to figure out what two numbers multiply to -1, well, it's only going to be 1 and -1, but if you FOIL that back out, it's not going to work. You're not going to get the right numbers. So if you try to factor that, you'll find that we really cannot factor that. So we have to use the quadratic formula. Now, we could complete the square. But you never want to complete the square unless you're forced to, because completing the square is the most difficult way to solve the to find the x-intercept. So b is -3. So plugging in -3 for b. And a is 2, and c is -1. So let's move all this stuff over a little bit. Make sure that root goes all the way over everything. A again is 2. So now we just have to simplify that. That's a double negative, so we get +3 plus or minus root 9. -4 times 2 is -8. -8 times -1 is +8. 2 times 2 is 4. So we have x is equal to 3 plus or minus root 17 over 4. Now this is very difficult to work with. But we know that root 17 is between root 16 and it's between, root 25. The reason we care about root 16 and root 25 is we know root 16 is 4 and we know root 25 is 5. So we know root 17 must be between 4 and 5, and it's closer to 4, obviously, because root 17 is closer to root 16. So we can estimate root 17 to be approximately 4.1. So if that's 4.1, 4.1 plus 3, that would be 7.1. And 7.1 divided by 4 would be approximately 1 3/4, somewhere around there. 1 3/4. 1 3/4 is going to be approximately there. Now again, approximating root 17 is 4.1. Now we have 3 minus 4.1, which will be about -1.1 divided by 4, which we can approximate as -1/4 approximately. So now we can connect the dots, and we could be more precise. Maybe if we plug in 2, we get 4 times 2 is 8. 8 minus 6 is 2. 2 minus 1 is 1. So that kind of helps us. We have that point there. Again, you don't have to find that extra point there, but it gives us kind of a guide. And so our vertex is 3/4, -2 and 1/8. And our y-intercept, which they specifically told us to find, is 0, -1. So our x-intercepts are 3 plus root 17 over 4, 0, and 3 minus root 17 over 4, 0. Let's go back and check everything. Make sure we did it right. write the coordinates of the vertex, we did that. Y-intercept, we did that. X-intercepts, and we drew them on the graph. So if you got that one right, excellent. So that was the class today. If you'd like to take screenshots of this practice test that we just completed to help you study for the test, go ahead and do that now. Here's screenshot number 1 and screenshot number 2 and screenshot number 3 and number 4 and number 5, number 6, number 7, number 8, number 9, and number 10. But don't go before you get your practice test for homework. I want you to complete this practice test for homework. Here's screenshot number 1 and screenshot number 2 and number 3, number 4, number 5, number 6, number 7, and number 8. But don't go before you get the answers. Remember, it's not enough to just attempt the test. You have to do it correctly. So here's screenshot number 1 of the answers. And here's screenshot number 2. Remember, these practice tests are not optional. You must get this practice test done before taking the test in the next class. And remember, if you want to get a really, really high score, you need to make sure that you can do every variation of every problem, not just the variations you see on these practice tests. So get that homework done, and I'll look forward to seeing you in the next class.